Hi, this is Nazrul Islam from NRSA International Limited. Today, I am going to show how to install and use our QGIS plugin for running clustering and routing algorithm. The plugin we developed can be installed with QGIS version 3 or above. It also requires PostgreSQL database 9.6 or above with PostGIS version 2.3.3 or above. We need Python 3 or above, the plugin file in compressed zip format. We also need a geodatabase with lines, poles, structures, roads, and administrative boundary like district and division. In my local machine, plugin compressed zip file is kept in this folder. This is the folder, and here is the plugin files in zip format, and I kept the geodatabase in this folder, and all output will be generated in this folder. Now let us start QGIS. Let's go to plugins folder, plugins menu, and manage and install plugins. We can install plugin if it is in zip format by clicking this install from zip navigation menu item, and we select the zip file by clicking here. This is our plugin, and if we click on this button, install plugin button, plugins will be installed. Here it says plugins installed successfully. Now close this screen, and this is the toolbar button for our plugin. Let us drag it from here and place it here, so we will get a more working area in our QGIS. Now click on toolbar button for the plugin. We get this screen. This screen has multiple tabs. One is general information, one is import table configuration, process control, layer control, and in general information tab we have two tabs at the bottom, that is PyTemplate and import SQL template. And we have some input fields in general information tab. If we follow some conventions and use the defaults, we do not need to write a single line of code for using these plugins. I assume that all the defaults are used. In general information tab, we need to provide some information like user. This is Postgres user, a built-in user in PostGIS database, and the password for these users. And we also need select the geodatabase file. And if we click in this button, it will open a file dialog box. From here, we can select the geodatabase file. We also need to set the Python path. This is the installation folder of Python, and also the bin folder of PostgreSQL installation. we can directly write it here, or we can select it by clicking this button. If we click on this button, a file dialog box opens and we can select the folder. Like this. Similarly, we can select Python path, and we also need to give the installation path of QGIS bin folder. And these parameters here, like host, port, and database, this is PostgreSQL installation specific. Host is usually localhost if this plugin and database on the same computer, and default port for PostgreSQL installation is 5432. We give a name to the new database that will be created, and after this we click on this button, save button. It prompts for confirmation. If we confirm it, data is saved. After these informations are saved, we can go for actions, like if we click on create PG database, it will prompt for confirmation. Do you want to create PostgreSDB from provided information? Yes. And a database is created with the name we provided. Then if we click on create extension, yes, and database extensions are created. Now to run some script, we need help of PSQL, and this is internally we need a command file that will be created if we click on this button. So command run cmd is created successfully. Then we need to click here create libraries. Yes. Then library files are created. This creates actually some state procedures in PostgreSQL in GeoTools schema. This may take some time. Okay, after this, let's close this command window. Then we need to create import scripts, but before creating import scripts, we need to give some information about what to be imported. For this, we need to go to this tab, import table configuration. For import table configurations, these informations are imported from geodatabase into PostgreSQL database, like district, lines, poles, roads, service territory, and structures. These are the PostgreSQL table, and these are the corresponding layers in geodatabase, and these are like district, line, pole, road, region, and structure. So if geodatabase has the layer names similar, then we can keep this default, but if they have different layer names, we can place regular expressions here that is a bit complex for new users. But as our GIS people told me that they will follow these structures, so we do not need to change anything here. But if we make any change here, we need to save data here, so it will be saved before creating the import script. Now let us go to general information tab again and create import scripts. So import scripts are created. Now we can import data from geodatabase by clicking on this button here, import from GDB. So it opens a dialog box with scripts and a command file, and before execution of import table command we can change these Python files if required, but if we use all the defaults and do not change what was told to us, we do not need to change anything here. Just if we run this script by selecting and pressing enter, or just by double clicking on this file, it will start import layers from geodatabase into PostgreSQL tables. Let's run this. So layer import started. So let us close this file open dialog box. At this stage, all the layers from geodatabase are imported into a schema of PostGIS database in import table schema, but for running or clustering algorithm, we need to insert those tables data into GeoTools schema. We can do this by clicking on this button. Yes. So it started importing data from import table schema to GeoTools schema. It is done. So at this stage we are ready to run clustering algorithm. For this we need to go to process control tab, and clustering and routing algorithm are running. So clustering and routing algorithm will be executed based on the selected locations. For this we need to load location. So locations are loaded from PostgreSQL database, and we need to select the location by clicking on this checkbox here, and we need to save this information by clicking save location button. And we also need some parameters. We can check what are the default parameters by clicking on this button, load parameters button. And here this is the revision text, actually revision tag, and minimum transformer size, household ratio, and monthly kWh consumed per consumer. And we can change these parameters. If we change these parameters, we need to save these parameters by clicking on save parameters button. Sorry. So before running clustering algorithm, we need to go to this tab, process control tab, and click on load location button. And we need to select the region for which our clustering and routing algorithm will be executed. We need to select the location and click on save location button. Then we need to click on load parameters, and we can change these parameters like minimum transformer size, household ratio, and monthly consumption per consumer. And if we change it, we need to save these parameters by clicking on this button. So locations are selected and parameters are set. at this stage we are ready for running the clustering algorithm. We can run the clustering algorithm by clicking on this button. If we click on this button, it prompts for confirmation, and yes, it confirm. So execution of clustering is going on. It may take long time depending on the volume of data in the selected locations. And I'm pausing this video while clustering is going on. So clustering is completed. Now let me close this window. Next stage is running the routing algorithm. And before running the routing algorithm, we need to normalize the roads. And road normalization is done for the entire location. This does not depend on the selected locations, and it needs to be done only once before. So once road normalization is done, we can run the clustering algorithm and routing algorithm anytime after, even if we change the parameters. So let me run the road normalization process. So road normalization is started, and this may also take very long time. So I am going to pause the video while it is running. So road normalization is completed at this stage, and we are now ready to run routing algorithm. So let me close this window, and for running LV routing we need to click on this button, and after confirmation LV routing starts. And this may also take long time, so I'm pausing the video. So LV routing is still running, and based on the volume of data and number of structures or lines in the selected areas, all this algorithm takes very long time. It may take more than 2, 3, 4 days to finish running the algorithm. And while it is running, it is recommended not to interrupt QGIS software. And this is why I think that it is better to have a separate executable for running all this algorithm without any dependency on QGIS. And I also have created those applications. So I have created another application that is executable and compiled natively for Windows, that runs even faster and that does not have any dependency on QGIS. But anyway, QGIS plugin is also created and ready to be used, and this is written in Python, and we have used PostgreSQL, and also we, in some places we took help of one executable of PostgreSQL, that is PSQL. For this we have also created some internal command file. So LV routing is still going on. Let me pause the video again. LV routing is completed, and let us close this window. Similarly, we can run MV routing, then we can run project creation and create output, and depending on volume of data and number of structures in selected regions, all this process may take very long time. but the regions we selected had very small number of structures, around 50,000 or so. So let us run MV routing. Yes, MV routing is started. MV routing completed. Now let us execute project creation. So it is done. And finally, let us go for creation of output by clicking on this button. Yes, and all output files will be created in this folder. So let us click on generate output command. This is a command file. So outputs are created and all these files are created in this folder. So we can make zip file from this folder and send it to our GIS team for their use. Now let us close all these folders, and this is how the plugin works. And if we want to run the plugins, run the algorithm again by different parameters, we can change the parameters, save it, and can start running from clustering, LV routing, MV routing, and project creation, and we can create different sets of output. As I told earlier, that this process for running clustering and routing algorithm may take very long time, and for that time period QGIS should not be interrupted. But okay, if required, QGIS can be used without closing this plugin window, but recommended is not to interrupt QGIS. But if we use separate executable that has no dependency on QGIS and that is natively compiled application, so while plugin is running, QGIS can also be used. So if it is required, I will come up with a different video how to use that application, and that application was also developed. Actually, that application was developed before creating this plugin. Okay, thank you for watching.